friction and types of friction. That means to say the static friction, kinetic friction, and as well as a rolling friction. In that case, now we are going to discuss about angle of friction. What is mean by the angle of friction? Here we are going to discuss when a block is placed on the horizontal surface. When a block is placed on the horizontal surface, we know that the normal reaction is acting perpendicularly upwards to the surface, and weight acting vertically downwards, that is W is equal to mg acting vertically downwards. So whenever it is in static condition, the limiting frictional force will act. Whenever the resultant force is acting in this direction, then the limiting force is in this direction, means the limiting friction is acting in this direction opposite to the applied external force. So that when the parallelogram drawn from the if that ON will in this direction, we consider this A and this will be B, means the normal reaction considered as A, and the limiting friction which is acting opposite to the applied force is considered as a point B. Then this will be the resultant for the normal reaction and limiting friction. This will be the resultant force acting between normal reaction and limiting friction. So that we can say the angle of friction means the angle made by the resultant of normal reaction, the angle made by the resultant of normal reaction and limiting friction. This will be the resultant of normal reaction and limiting friction. So that the angle made by the resultant of the normal reaction and the limiting friction with the normal reaction is called angle of friction. It is denoted with pi. Once again, the angle made by the resultant of normal reaction and a limiting friction, this will be the normal reaction and this will be the limiting friction. This is the resultant which is acting between them with the normal reaction. The angle made by the resultant of normal reaction and limiting friction with the normal reaction is called angle of friction, and that is denoted with pi. So that when the normal reaction and resultant and the limiting friction is whenever we combine as parallelogram, this OA be the normal reaction, OA is a normal reaction, that is considered as N, and OB be the limiting friction, and OC be the resultant force acting between them. So that here when we draw a parallelogram and resolve this, then we can get that equation from that, that is triangle OAC, means OAC. This will be the triangle we are considering because of angle made by this one, so that's why we are considering this triangle. So that we know that the tan pi which is tangentially acting, so that's why we are considering as a tan pi we know that opposite by adjacent. So this will be the opposite and this will be the adjacent. So AC by OA, AC is parallel to OB, so that's why we are writing AC by OA is equal to OB by OA, that is equal to OB is equal to limiting friction and OA is equal to normal reaction. So that's why FL by N. But we know that FL by N means the ratio of static friction to the normal reaction is called as a coefficient of static friction, that is equal to mu s. So that tan pi is equal to Fs by N, that is equal to mu s. From that equation, mu s is equal to tan pi, means that means to say the angle between the normal the angle between the resultant of the normal reaction and limiting friction will with the normal reaction is angle of friction. When the angle of friction increase, decides the value of the coefficient of friction, means here if the greater angle of friction, if the angle of friction is more, if the angle of friction is more, then a coefficient of friction will be also, value also will be more. So, greater angle of friction gives the greater value of coefficient of friction. So, angle of, this one is the about angle of friction. Once again, angle of friction means here the angle made by the resultant of the normal reaction and the limiting friction with the normal reaction is called angle of friction, that is mu s is equal to tan pi be the angle of friction. So, this is about angle of friction. From this one of the application for the rolling friction is pulling and pushing pushing and pulling of a lawn roller. We are going to discuss about it. First of all, here when a lawn roller is placed in the horizontal surface, we know that when the horizontal surface the lawn roller is placed, the weight due to the gravitational force acting mg is acting vertically downwards and always normal is acting vertically upwards. Means now first we are going to discuss about pull. Means whenever the body is pulled in this direction, the force is acting in this the resultant force acting in this direction. That is whenever the body is pulled, the resultant force is acting in this direction. So that if we get the components for this force, the components for this resultant force, the horizontal component will be f cos theta and vertical component will be f sin theta. Means the mass of a body is mv, lawn roller mass is mg acting downwards and a normal reaction upwards. The resultant force is acting in this direction, so that if we get the components of this force, then we can get f sin theta is vertically upwards and f cos theta will be horizontally along surface, so that here when the body is, the resultant pulling force is acting in this direction, then if we consider that the n and the component vertical upwards f sin theta is acting same direction, so which is equal to the mg, net force is acting in the direction. So whenever the normal reaction plus f sin theta, the vertically acting component is f sin theta, which is equal to the mass weight, which is equal to the weight mg. So that's why we are writing that. But then how much the normal reaction is acting? Then n is equal to mg minus f sin theta. mg minus f sin theta. But we know that the rolling friction, according to the rolling friction equation, the coefficient of rolling friction, we consider it's equation number 1, that is coefficient of or either rolling friction. The body is rolling in this direction. Whenever the resultant force is acting in this direction, the body must move in this direction horizontally, means in the direction of the resultant force acting in the direction of, in this direction, in the body is moving in the direction of f cos theta. F cos theta more than the Fr means the rolling friction, means against the rolling friction the body is moving in this direction, means some of the external force acting more than the Fr. So that's why then what is that external more force is acting on that body, we should remember. So first of all, rolling friction, due to the rolling friction acting, so that's why Fr is equal to, we know that mu r n. So we are substituting in that equation, then the n value in the above equation, then we can get that is Fr is equal to mu r into mg minus f sin theta. So that we are multiplying inside, then we can get that. Either if we put that same also, we don't get anything. Fr is equal to mu r mg minus mu r f sin theta. So that consider equation number 2. From this equation, then what is the net pulling force acting in this direction, means more than the rolling friction, which is opposes the motion, relative motion on that, then which opposes the rolling friction is opposed by the surface, more than the Fr is the of the force is acting, that is net pulling force. Net pulling force that is considered as a P1, that is equal to body is moving in this direction f cos theta in this direction. So that's why the net pulling force is also acting on the direction. So that's why that f cos theta minus more than the frictional force. So that's why rolling friction Fr means it is more than the rolling friction. The net pulling force acting means how much the extra net force used more than the frictional force, how much the force I have used to roll that lawn roller by pulling. So here P1 is the net pulling force and f cos theta is in this direction. Net resultant is moving in the direction more than the how much the force has used, that is f cos theta minus Fr. Means if in case of if the body resultant force is acting in this 10 Newton, then opposite of f cos theta is acting in the 15 Newton force as used, body is moving in this direction, then how much the net pulling force which is used, means this is f cos theta and this is Fr, means Fr is acting in this direction, f cos theta is in this direction. So that we can get that how much the net pulling force is there, means more than the Fr. That means to say 15 minus 10 is equal to 5 Newtons be the net pulling force which is acting like that. So here is also we are getting that the net pulling force which is P1 is equal to f cos theta, body is moving more than the Fr. So that's why minus Fr we are writing. So that is P1 is equal to f cos theta minus Fr. From equation 2 we know that mu r mg minus into minus plus mu r f sin theta, mu r f sin theta. So from that equation we can write that f cos theta is there, f sin theta is there, we are taking f as common. So that's why cos theta plus mu r sin theta minus mu r mg means here we can write that is the equation for the pulling force, pulling force. Next we are going to discuss about pushing force. Here we discussed about the pulling, now we are going to discuss about pushing. So here is the lawn roller is placed on the horizontal surface. Consider it's a lawn roller is placed on the horizontal surface, this is the center, and we know that mass due to the gravitational force mg, weight is acting vertically downwards, and normal is vertically upwards, as we know that. Then pushing means when the force is acting like this in this direction, then the resultant force which is acting in this direction means pushing force is this one, means the net F is acting in this direction. Then with the whenever it is acted, then with the horizontal that will be the theta. So that here if we take the components of this force, resultant net force is acting in this direction, then this will be the f cos theta, horizontal component will be f cos theta, and the vertical component, vertical acting downwards, is f sin theta. In this case of pulling force, the f sin theta acted vertically upwards. In case of pushing means the force which is acting in this direction, means net force is acting in this direction. So that when the force is applied on the external force is applied on the body, resultant force, that is rolling friction, is acting opposite to the net resultant force. So that's why F is acting in this direction. And as well as if you see practically almara or birwa is there in our home, then whenever we push that one from a side, then the edge of the opposite, whenever we are pushing like this, means whenever we push it, consider it's a almara, whenever push it from this, then the total almara moves this side, but the total force is acting in this direction. Whenever you push this one, then the force is acting in this direction like this. So that's why the net resultant force is acting in this direction. So here it is that the net pushing force acting in this direction, and rolling friction will be in this direction. So consider lawn roller of weight mg is on a horizontal surface, pushed pushing force or pushing force F at angle theta. We know that theta. Here if we take the components for F be solved into components, be solved into components, then we can get that is F sin theta is vertically downwards means along the weight, in the direction of weight, the F sin theta component of resultant force F sin theta is also in the same direction. Then F cos theta, if we take the F cos theta is horizontally along a surface. So here it is that whenever it is acting, then what is the normal reaction? Means equal amount of normal reaction, the F sin theta and mg is acting in this vertically downward. So that's why we can write directly that is the normal reaction n is equal to mg plus F sin theta. Consider this equation number 1. From the rolling friction, because of whenever pushing or pulling, the body will roll, non-roller will roll. So that's why Fr is equal to mu r n. From this equation, Fr is equal to mu r into, if we substitute that one, mg plus F sin theta. We are substituting the equation number 1 in the Fr is rolling friction is equal to mu r into n. So from that equation, consider it's equation number 2. Now pushing force, as we know that the pushing force P2 we are considering, the pushing force is considered as a P2. Let's see. The body is moving along the F cos theta in opposite direction to the Fr, same as force which is utilized, means same as pulling force, as we read that one, P1 is equal to F cos theta is equal to F minus Fr. So same as here also, same the time of F cos theta, the body is moving in the direction of F cos theta more than the frictional force, rolling friction is acting more than that. So that's why minus Fr. Here is also we wrote that about the pulling force, the P1 is equal to F cos theta, body is moving, resultant body is moving in this direction, F cos theta is maximum. How much is there? The maximum value more than the rolling friction is acting on that body. So that's why the body is rolling in the direction of F cos theta. So that's why F cos theta minus Fr, that much of amount of pulling force which is acting means more than the friction, rolling friction, some of the force is acting on that body. Then what is the extra force? More than the frictional force, that is considered as a net pulling force. So that here is also pushing force means P2 is equal to F cos theta is equal to Fr, means some body is moving in the direction of F cos theta more than the rolling friction is acting in this direction, means more than the rolling friction, some of the external force is acting on that body. So the what is the total external force, external force which is acting on that body, means that is the net external force due to the body is rolling, because of the external agency is acting on that body. How much that one? That is net pushing force is that P2 is equal to F cos theta minus Fr. So that's why P2 is equal to F cos theta means F cos theta, and here Fr means we know the equation mu r mg. We are substituting inside, we are multiplying inside, minus into plus, minus mu r F sin theta, mu r F sin theta. Here is also we can write that same equation, Fr is equal to mu r mg plus mu r F sin theta. Consider this is equation number 2. Consider this one is equation number 2. So from that equation we are substituting minus into plus, minus into plus, minus. From that equation we can get that. So F is common, so that's why we are writing that. That is here F of cos theta minus mu r sin theta into minus mu r mg. This will be the equation for pulling, this will be the pushing force. This is the pushing force. So we know that here we got that P1 is equal to f of cos theta plus mu r sin theta. From this equation we can write that. From the equation we can write that here, whenever this taken this side, then P1 plus mu r mg by cos theta plus mu r sin theta, which is equal to f. That force is a pulling force. This is a pulling force. This is pulling force. And in case of this one, if we get that P2 plus mu r mg by cos theta minus mu r sin theta is equal to f. This one is pushing force. This one is a pushing force. So that's why here we can write that the pushing force will require more force than the pulling force. So we can say that the pulling force is less than the pushing force. That is a P1. The pulling force here is the net pulling force is less than the pushing force. We can write that. Means here from this equation we can write that the pulling is easier than pushing. From this equation we can conclude that pushing is harder than pulling. Or also we can write that pulling is easier than pushing. We can conclude with the two statements, that is pushing is harder than pulling, or also pulling is easier than pushing. Once again, here the pushing and pulling the lawn roller. When the lawn roller is placed on the horizontal surface, the weight is acting vertically downwards and a normal reaction is acting vertically upwards. The net force in case of pulling, the force is acting in this direction, the resultant force acting in this direction. Whenever we are taking that resultant force, then if we take the components of that resultant force, then that is a horizontal component will be f cos theta and vertical component will be f sin theta. So that here we are writing that here the weight is acting in this direction, then rolling friction is acting in this direction, means opposite direction to the applied external force. So that from that n and f sin theta is acting in the same direction, which is equal to the weight of the body. So that's why n plus f sin theta, which is equal to mg. N plus f sin theta is equal to mg. So that from that equation, normal reaction, here the normal reaction n is equal to mg minus f sin theta. From that equation, the body, due to that one, some of the external force which is acting on that body, whenever it is pulling, some body will roll. So from the rolling friction, Fr is equal to mu Rn, Fr is equal to mu R into mg minus f sin theta. We got that. So Fr is equal to, whenever we substitute that one, mu R mg minus mu R f sin theta. So from the equation, the net pulling force means so body is moving in the direction of f cos theta. So that the f cos theta value is more than the Fr, means the rolling friction. So that's why what is the net pulling force, how much the extra force which is used to roll the body, that is net pulling force here. So P1 is considered as net pulling force, which is equal to f cos theta minus Fr. Then only we can get that the extra force more than the Fr rolling friction, the force used on the to move in the direction of the f cos theta direction. So that's why P1 is equal to f cos theta minus Fr. By substituting the value, we can get that P1 is equal to f pulling force cos theta plus mu r sin theta minus mu r mg. That will be the equation for pulling. Then next, same the lawn roller, whenever we are pushing, either body is pulled, now pushing. Whenever pushing, the resultant force is acting in this direction. If we take the component same as the horizontal component will be f cos theta, vertical component will be sin theta. In the case of pulling, the vertical component is acting vertically upwards. In this direction, the vertical component is acting vertically downwards along the weight. So here according to the normal reaction f sin theta and weight is acting in same direction, so that's why n is equal to mg plus f sin theta. From the rolling friction, if we substitute that value normal reaction in the rolling friction equation, then we can get that Fr is equal to mu r of mg plus f sin theta. If we multiply it inside, Fr is equal to mu r mg plus mu r f sin theta, then what is the pushing force? Whenever the extra force which is used to push the body, that is P2 is equal to f cos theta minus Fr. If we substitute the equation, then we can get that is P2 is equal to f of cos theta minus mu r sin theta minus mu r mg. So from that equation we can get that here the pushing is harder than pulling, or pulling is easier than pushing a body. So this is about pulling and pushing, and as well as angle of friction.